I am ready for my end.
Cool. Then I'll hit the go live so we can enjoy this with other people, because honestly, that's way more fun than just being here talking with myself. So hello, everyone. Thank you for joining us for our first KubeCon deep dive. We're going to be talking about multi-cloud, multi-cluster Kubernetes with Terraform today. My name is Kareem Satirli. I'm a senior developer advocate at HashiCorp. And before we dive into our technical content, we're going to have a quick look at our community guidelines. Some really simple stuff. This is a public event. We're streaming it on YouTube. If you're watching this live and you have questions, drop them in the chat, but make sure you're welcoming, inclusive and friendly, be considerate and be respectful. There's real people working on our side. There's real people in the chat on the other side. Let's be nice to one another and have a good time, because that's the best way to learn in public. If you need the full guidelines, we have them on our site on hashicorp.com/community-guidelines. We'll have a link for that in the chat as well. And with that, let's get started. Let me switch over to my code editor. We're not doing slides here. And hello, everyone who's joining us. Hi, Tobias. Nice to have people from Germany as well and from everywhere. And let's have some fun. So if the magic of streaming worked out, then you should be seeing my code editor. And I'm going to need some help from you. For me, the font size looks big enough, but does it look big enough for you? Just let me know in the chat. We're monitoring. If it's not big enough, we'll bump it up. You should be seeing two parts. The upper part is the editor interface, the actual files we'll be editing or looking at, and the lower part is where we run commands. And welcome to all the folks that are joining us still. It's going to be fun. We're going to be setting up a couple of clusters. We couldn't figure out which cluster to deploy in which cloud, so we ended up deploying in Azure, in GCP, with DigitalOcean and Amazon. And what you're in for today is basically a single repository that will teach you how to do all of this with Terraform. So let's start out with some basics. This is part one of a three-part stream. And what we're doing today is essentially mimicking a platform team. That platform team right now is represented by me. My job is to deploy a Kubernetes cluster on 4 clouds. So my team can do something tomorrow and the day after. So tomorrow, part 2, my colleague Rosemary Wang will show you how to deploy console service mesh on Kubernetes, building on top of the stuff we're doing today. And then on Thursday, Rob Barnes and Nick Jackson will show you how to use Vault in the terms of encryption as a service for Kubernetes. So if you're joining us for all 3, you're going to have a pretty awesome deep dive experience, I think. And if you're just joining us for one of the parts, then clearly you made the best choice by being here today, because this is going to be fun. All right, so increase the font size a little bit. Let me know if this works. And let me make the Zoom window a little bit bigger as well. And let's see where this is going. And I just noticed that despite having everything on, you haven't seen me, so hello. Still Kareem. Very nice to see you all here. So let's talk about Terraform. Terraform is pretty much my favorite tool for this kind of job because it makes it easy to deploy things. But oftentimes you find yourself in a situation where you need to deploy stuff in multiple clouds and things get a little bit complicated. So what we're going to be doing here today is building our building block and making that available to our friends from other teams, our application developers, our In tomorrow's case, our expenses team, you'll get that way better tomorrow when you actually join that. And so what we'll do is we'll start out by defining our Terraform stanza. We're using Terraform Cloud for this for one simple reason. All of our team is working on this, so we want to share our state. And rather than passing around state files or committing them, we use Terraform Cloud. Our team has access to this. The nice thing about this is that I can share secrets without exposing them. I can make secrets available without sharing the actual contents of those secrets with my team. And that makes life for me a lot easier. So we'll start out by defining a couple of workspaces. And if you've ever worked with Terraform Cloud or Terraform Enterprise, same idea. Workspaces are essentially a way of limiting the blast radius of your infrastructure and defining specific tasks. So we started out by defining one very simple thing to limit our blast radius, which is we require a specific version of Terraform. You'll find this one in the repository, which we'll share with you later, defined everywhere because we want to make sure you're running the right version. This is not just for us, for you to upgrade. It is very much to ensure that your code keeps working, even when you view this in the future. And not just in the future, as in the other side of the planet that already is in tomorrow, but let's say you're looking at this code 3 months from now. We want to make sure it still works. So the way you do this, you define the required versions in your Terraform file. Next up, we've got a couple of workspaces. And let me actually show you how that looks like by going to our Terraform Cloud interface. Code is nice, right? But at the end of the day, sometimes it's easier to look at it in something bigger. Also, if anyone is working on a taco provider, please let us know. This is important to our team. We are aware of the pizza provider, but we need a taco provider for next week. So definitely help us out there. Switching back to Terraform Cloud, what you see in front of you is a handful of workspaces for all the clouds that we have. We've pre-deployed a few of those. We've killed a few of those again and then redeployed them for the fun of it. And the first one we start out with is the workspace. And the workspace repository will actually set up all these other workspaces for you. And before we dive too deep into that, we essentially define a little bit of configuration for all of this per cluster, making sure that we're in the right repository, we're choosing the right execution mode. In our case, we want to do it remotely because that makes it easy to work on this from the comfort of your tablet. Now, is that the standard workflow of an infrastructure engineer? Probably not. Is it nice to be able to correct mistakes while you're on your tablet? Definitely helpful. So we created a few of these workspaces. We put some validation in there and we're enforcing the 108 version also remotely. And with that, we're going to do our first kickoff and apply this remotely just to show you that it actually works. In our case, because the workspaces already exist, the whole process is super quick. We've got the workspaces defined with for each, which sometimes is one of those things people struggle with. So we have an example in there that you can also use. And we posted the link for this in the chat. Now, workspaces are nice, but the question really is, what do workspaces do, right? So let's have a look at our actual code. And I'm curious, for all the viewers, are you thinking about deploying on AKS or Azure, AWS EKS? Are you thinking about DigitalOcean or on your own Raspberry Pi cluster? What are you in the mood for today? And I'll give you a few seconds to answer while I grab something to drink. And I know this is scary sometimes talking in public, but just let us know. We're really curious what kind of cluster you prefer to deploy, what kind of cluster you prefer to manage. And probably the right answer is obviously you prefer to manage no cluster, but a Pi cluster can be one of the fun ones. Which happens to be the only one we're not doing today. But that doesn't mean you can't use half of the code that we have in here. So let's go with, okay, so we see 2 EKS, GKE. Let's do DigitalOcean. Because DigitalOcean is actually releasing a newer upgraded version of their Kubernetes cluster I saw earlier today. So we'll hype that up a little bit. When you look at the Terraform code, we're going to be going through at least one example today. We might be going through multiple clusters, but all of them are structured in the same way. So if you understand how, in our case, DigitalOcean works, you'll understand how the others work. So we'll start out by defining our Terraform stanza with a remote for the simple purpose of being able to share state across different teams. And this is important because it allows my teammates to consume resources I'm creating without me needing to communicate the actual words to them, the actual resource names or resource IDs. So we'll start out by defining a DigitalOcean provider. We're grabbing 2.14, which is the latest version. If you're building Terraform code like this, one thing I like to point out is version pin your stuff, always. There's no reason to not do it because it pays off in spades. If this provider gets upgraded and a feature gets replaced, a resource gets deleted, in general, Terraform will deal with that gracefully. But there are edge cases where it doesn't. By version pinning, you prevent those problems because what worked today will work in the future. And to answer Sergio's question, yes, we're structuring it by environment. In our case, we consider the different clouds environment, but you could make a substructure. For those that didn't see the question, Sergio asked, will you structure it based on environments using workspaces with that logic? Yes, we are. We're structuring it with Terraform Cloud workspaces and actually have a large amount of them here. But we're structuring it with a single environment in mind, and that environment is that specific cloud. So for EKS, we have one cluster deployed right now for the purpose of this demo, but you could use the code that we have and deploy multiple clusters. So let's go back to our Terraform instructions. When you build your code, always version pin. I like to add comments in there to make sure people can find that version of the provider. So if you click here, if your editor supports it, you'll get the 2.14 documentation. This is useful for our major providers as well. There's weekly releases, and something that you edited 3 months ago is essentially 10 to 12 versions behind. You want to always look at the right kind of documentation for the thing you're working on. And next up, our required version for Terraform. So far, super simple. If we're going too fast, let us know in the chat. We'll slow down a little bit and then go from there. Now, next up, we want to define a couple of providers. And in the case of DigitalOcean, this is a very simple configuration. All we need is a token, which we have available in Terraform Cloud. This is super nice for me because I can put it in there. I can use Terraform to actually put that token into Terraform Cloud, which there's always a bad joke there that we're using Terraform to configure Terraform Cloud so Terraform can run. But bad jokes aside, even putting your secrets in like that can be useful because it means more of this process is automated, and that means less chance for humans to actually make a mistake. And the other thing we're defining here is an API endpoint. Generally, I'm going to say this is an extra that you shouldn't be concerned about, but if you happen to be talking against a different DigitalOcean API, then you can change the API endpoint here. Now, so far, we've defined our providers. We've configured our provider with the right token, hopefully. And the next part that we're going to do is we're going to define a cluster. Like before, we're adding some commentary on the resources. Generally, just a good habit to help people who read your code to understand what your code is doing and how it's doing that. And the best way to do that is to think 3 months down the road, are you going to remember the exact page? Is your browser going to remember the exact page? Or would it just be easier to have that link in there? Our team generally just puts the link in there. It works. It makes life simple. So next up, we're configuring a few things on our cluster. We've disabled auto upgrade mainly for the purpose of the demo, but that's also an organizational choice. Your company or your team might say, you know what, I'm totally fine getting all the latest versions all the time because I trust my provider to do this. It's generally what we do as well. It just, for the purpose of this demo, we didn't want it to upgrade mid-demo because sometimes that doesn't work out. And if you know anything about live demos, then you know that the demo gods always choose the worst possible moment for you to do things. We do have a maintenance policy in mind, though. Ours is 3 a.m. on Monday, which basically means you wake up, everything should be done. And if not, then at least you know how your week is starting. So either way, sounds like a great start of the week. No questions, no need to do other stuff. Next up, we're defining a node pool. In our case, we've got 8 GB instances, 3 of them, because that's how much we need for the rest of this demo. But as with all the questions, whenever people ask, like, what's the right size? The thing you're looking for here is a book called The Art of Capacity Planning that will help you learn how to make that choice. None of us is qualified to give you that information for your environment because there's a lot of interesting stuff that's happening on your side that we're not going to be aware of. For our use case, the 4 vCPU setup with 8 gigs of RAM works just fine. We're defining a region. I think for all these demos, we're trying to stick to California. So if you deploy this and run your own workloads, you will get blazing fast speed. And then finally, of course, if we're deploying a kube cluster or any kind of cluster, we need to define a software version. And there's 2 ways to go about this. In Terraform, we could define this as something like 119, 120, all the other versions that DigitalOcean has available right now. I think 121, not actually sure if that one is in there. Let's have a quick look. Yeah, 121.3 is available. So we could set that, but in our case, what we do is we want to make this as hands-off as possible. So we are using a data source. And specifically, DigitalOcean has a data source for Kubernetes versions, which we have here. And we're essentially saying, give us the versions that have the 119 prefix, which is 2 versions behind. But because our server is not set to auto upgrade, we're not going to get any problems here. And I think our version is 119.3. And the way we can test this is by having a look in our Terraform console. So let me start that up. And so this is one of the features that are highly underrated, but very cool to try out with. Terraform Console is essentially a way to peek at the resources you're using. You could do this by looking at the state file. You could do this by using tons of outputs. The Terraform Console is just a more interactive way of doing the same exact thing. And so in our case, we have a data source here, which would be called data.DigitalOcean Kubernetes versions.cluster. And when I run this, I can see what my name here is. We're doing a version prefix of 119, as you saw before, and the currently valid versions for this 119.13. So if you're developing Terraform stuff, trying these things out, this is a super nice way to learn more about the resources you have. Terraform Console works for pretty much everything. You can do operations in there. You can test out how your for each works. You can do additions, subtractions. Every Terraform function that is available also works in the console. And for us right now, we don't need anything from the console. So we'll go back to our code. We've got our data source, which gives us the latest version for the 119 prefix, which ends up being as 119.13. That's perfect. And then the next thing we want to do is run our code and see if we can actually get a cluster here. And let me quickly check in another window if my colleagues are using that cluster, because if not, we might just tempt the demo gods and live deploy a new cluster. So there's a couple of ways of doing this. I think the first one, the easiest one, in our case, we're going to comment this, which basically makes it invisible to Terraform. And then we're going to rerun our plan. And of course, because we still have an output, which we're going to talk about in a second, this is the beauty of live demos. You can script everything in your head, but sometimes you do things and they don't work out the exact same way that you have them in mind. So in our case, we've disabled the outputs. We've removed the cluster, and Terraform agrees with that. So we're going to kill our cluster. And let me switch to DigitalOcean real quick. Of course, this is still running. There we go. Apologies for the quick window switching. But the easiest way often to show you things is sometimes the absence of it. If you're watching this on repeat, this is going to be much easier because you can just go back 10 seconds and see the window at that point, which showed a cluster. And that same window now doesn't, and shows us the getting started screen because we just killed our cluster. So far, this is going well. We're able to destroy infrastructure. Yay us. Now the question really is, are we able to bring back infrastructure? And we're just going to do an apply with auto approve. Small caveat there, auto approve means that Terraform will just go charge forward with whatever instruction you've given it. As you know, stuntmen like to say, I'm a professional. Don't do this at home. Only do this at home if you're actually aware of what you're doing, or in the home office or a remote office, wherever you are, because sometimes this can get a little difficult. So while this is running, let's see if it's already registering here. There we go. Our server is being created with 119 again. And Terraform is running. This is always very exciting. You know, you test these workflows and you make sure they work. but there's a lot of things that can go wrong. And especially when you're doing everything very remotely, it's different. It's definitely different. So while we wait for the countdown to our new cluster, I'm curious, where are you all deploying from? Are you live at KubeCon? Are you remotely watching? Just hanging out in your hotel because getting back to in-people conferences is really weird right now? Let us know in the comments. We probably have another 30 seconds left for this. And, you know, like filling up the time here, I got a suggestion to sing and I was like, we can't do this. We have a community code of conduct. We need to be friendly and respectful to people. So that's why we're not singing here. Just looking at our infrastructure make waves, positive waves, which is not a DigitalOcean pun, I promise. So while this is working, one of the things that you noticed beforehand, when I disabled the resource to destroy it, we had Terraform Bark at us for essentially having a couple of references that didn't work out. And those were our outputs. So if, yes, there we go. You should be seeing my outputs CF file right now, which contains a couple of items that we need for further consumption. So we're outputting our cluster ID, cluster name, cluster region, and just for convenience sake, our console URL and our Terraform workspace URL. And those things we've defined dynamically. So that means if you run this and you go into your variables file or our variables file, and it changes up from San Francisco to any other zone, New York, or you change the prefix, then this will reflect in the outputs. And this is important because what we're doing with this repository is giving a promise to our application developers that they will be able to get the data that we have here through Terraform outputs. And that removes a little bit of glue. And I'll show you what that means in a second. But before we do that, we're going to wait until our cluster gets deployed. The downside of picking a somewhat beefy setup is that it always ends up taking longer. See, Ahmed is joining us from home. Very nice. The best office chair is there because it's the one that you choose. No matter if that's an actual office chair or just a huge sofa. And so far, you can see this is not a pre-recorded demo because otherwise we would have definitely not made this last 3 minutes and 60 seconds, 50 seconds. We would have just made this appear in the blink of an eye. But as it is, what Terraform is doing right now is Terraform is an API client that wraps providers like DigitalOcean, AWS, many others, not just cloud providers, but also tools like Datadog through an API and exposes that API to you through a language called HCL. Now, if you're thinking about deploying infrastructure with Terraform, you very likely have used HCL before, but if not, what you're seeing on screen right now is HCL. It's a language that we use for all of our tools. So if you're thinking about picking up a new language and if you're into infrastructure, I can highly recommend this one. It's a configuration language, so it's not burdened by the possibilities of higher level languages where you have many more options that sometimes only add abstractions, only add confusion. We're typing something out here that anyone who spends about an hour with this language should be able to understand. And that's important. Because when you have a language that you understand, that means you can have empathy for the people that built this. you can understand that, hey, you know what, these 3 lines, my worker pool, they convey a story. They convey a story that my 4 vCPU setup maybe is the best possible choice right now for our startup's budget, but maybe that's really way too low powered. Now, obviously, we're dramatizing this a little bit, but if you think about it, the infrastructure you deploy, that's not your job, right? The infrastructure you deploy provides value for something. It provides a way to run software, to run a database, an analytics package. Maybe it runs your mobile app. So all of these lines, they really, really convey a story that help fit into the narrative of your company. So by understanding this, by making it accessible in terms of readable, human readable, you're creating equity for everyone to just see what's going on and to remove confusion. Now, as most infrastructure engineers, I guess we're all a little bit lazy in the sense that we don't want to do boring stuff. We want our technology to be boring in the sense that we don't want it to cost us brain cycles to understand what's going on, but we don't want to bore ourselves with doing boring stuff. So in this case, this doesn't bore me because I understand it in a few seconds. Hoping for you it's the same. If that's not the case, or if you just want to expand your knowledge, we've got a handful of really good tutorials available on our Learn side. We'll have a link for that up in the chat notes, in the show notes as well. If you're joining us later, easy way for you to get that information. And so while we were talking, took us 5 minutes, 2 seconds to deploy a new cluster. I'm going to quickly switch to DigitalOcean again. And it looks like our cluster here is ready. Wondering if there's a good way. Well, we can see that this was created 7 minutes ago. So apparently we talked 2 minutes over the time limit. But we're here, and this is working. So far our platform team is doing amazing, right? We started 35 minutes ago. We talked a little bit about how we can use infrastructure as code to do all these kinds of things and how to deploy clusters in this case, DigitalOcean. But now the next part is we want to make this accessible to other teams further down the road. So let's have a look again at our outputs. And you can see here, we've got our stuff predefined as we had it before. And if we just print out the outputs, then we should be good. I think my screen froze there for a second, but let me see. I think my console froze. That's the problem. While we fix that, 1 second. You have to think about these outputs that you should still be seeing on the top of my screen as ways to communicate information from Terraform to either other Terraform projects or to tools outside of Terraform. So let me see if that works. Sometimes what happens with editors like this is that the console just gets stuck a little bit, which can be frustrating. Well, we'll work through that. And we'll just grab a different setup. And let's see if we can get it to work here. Apparently not. And we'll work with this one. So I switched to a different editor, I quickly restarted it. You should be seeing it still at the same font size. If not, let us know in the chat. But I think we should be good here. And you'll see one of the things that we're doing in the doc space. So we've got our outputs defined. And let's get those deployed and switch back to Terraform Cloud. And so the reason we're running this in Terraform Cloud is that if I run into any problems, I can ask my colleagues to help. I can run this pretty much from anywhere as long as I have access to an editor, which makes this powerful for me. Because that means, one of the things I do with Terraform is maintain Twitter lists. There's a provider for that. This is not how the tool was designed with that in mind, but it is one way of using the tool. The way I edit this list is essentially go to GitHub and use code spaces. Edit the file, Terraform Cloud picks it up, automatically makes the changes, and we're good. This is important because it lowers my response time to mere minutes. I don't need to have the full stack installed. I don't need to have all the tooling available locally. If I'm confident that my code works, and through the power of GitHub Actions in this case, I can do a lot of good stuff. I can make sure that all my stuff is properly linted before even going there. I can essentially easily say, you know what, this is exactly what I want, and this is how I want it. And so Zoom is acting up a little bit today, but we'll see if we can make this work still. Or not, sorry, not Zoom. My editor is acting up a little bit. Zoom is doing just fine. But let me switch back to my browser because that gives you a better story. So I've got a change that triggered via the CLI. My editor decided to not collaborate with that. But the important part is you can see these 5 outputs, not 4. And we're gonna get to that question in the chat in a few seconds. Quickly want to show the outputs we have here. Our team agreed to have all these outputs with similarly named interfaces. So we've got a cluster ID, name, and region. And the reason that's important is that we can use a Terraform data source to consume these. I think we already pasted the link for the code in the chat, but to give you an idea, if you're using this code, we have a little bit of a sample code in there for how to use this for downstream consumption. And the way you do this is you use the DigitalOcean Kubernetes cluster data source. And this is, if you think about Terraform in terms of an API client, this is a read resource that essentially pulls a remote API and queries it for all the clusters with the name multi-cloud K8s, K8s. If you're changing the name, obviously this example will need to change as well. But if not, you're golden. This will give you the information you need. And this is really important because when you want to deploy workloads on Kubernetes, you'll need a cluster certificate, you need a client certificate, you basically need the whole KubeCon config. Now I could store that in Terraform outputs, but that seems like not the best approach. It means that for you to consume the latest version, I need to run my workspace again. It means that you need to trust that everything in there is secure, that it hasn't been modified. This is all very fragile. It gets too fragile for what we want to do. So the way we're doing this, in our case, I published a name for you, which is what's really important here. And you can then consume that name through that data source. And this is magical on a couple of different levels. The team downstream that wants to deploy their workload on Kubernetes doesn't care if I deployed this to EKS or AKS or what version they deployed. All they want to do, let me switch tabs here. They want to know how it was deployed, what the name is, and how they can consume it. So in our case, we talked about this a little bit. We've deployed a couple of different clusters. And what you're seeing here are the outputs for all those clusters. And you'll notice we're using the same name just to make it easy for our consumers down the road. So our platform team is giving you an output that contains a dictionary or an object with all the different cluster names and some extra information just for convenience. I like having URLs in my terminal because whenever there's a question how things are working, or if I want to share the state of something, not the Terraform state, but the progress, I can just paste them the URL, share that on Slack, Discord, whatever tool you use. And somebody else can just jump in there and see, all right, so let's grab our workspaces, these ones, and we can see we're actually retrieving 4 different clusters here. You can see some of them were updated today, others were updated at other points, and here we have our output. And so if we quickly refresh this and go back to our outputs, you can see DigitalOcean has some of the stuff in here. Doesn't render pretty on the screen. That's okay, because this is a complex object. It's not meant to be rendered on screen. It's meant to be consumed through Terraform. And this is where this gets a lot of fun. We've deployed 4 clusters. And now I only showed you DigitalOcean, but you can see on these links that we have others available. So let me switch to Google Cloud. Actually, not the compute engine, but the Kubernetes workloads. You can see our cluster here is deployed. We've got 9 nodes and 144 gigs of memory. And our monitoring is already telling us that we're low on resource requests because we haven't scheduled any workloads. So let's have a quick look, a little bit of a preview into what we're going to be doing tomorrow. But before we do that, Biswarup has a good question, and is coupling managed Kubernetes with deploying workloads in the same Terraform module a good practice? And these are the kinds of questions where if you ask 3 people, you get 3 different answers. I would say no, for the simple reason that you want to limit your blast radius. The team that deploys the application on Kubernetes, the workload, might not be the same team that operates the cluster. That's totally okay. Maybe it is the same team, and maybe you just want to limit the amount of things that can go wrong. Put those into different states, and life gets a lot easier. Because rather than have to worry about the cluster, all I have to worry about is a cluster ID. And so that's what we're doing here. We're separating, I don't know how well visible the sidebar is, but we're separating our clusters for AKS, DigitalOcean, EKS, and GKE from our workloads. So if you're in the clusters directory, apologies, if you're in the clusters directory, all you have is a barren cluster that runs nothing other than what the cloud providers put on there by default. Those are the things we don't touch necessarily. But even if we do, I don't want to make that choice here. Remember, today's part of the story is that we're the platform team. We're representing a team that provides a way for other teams to run their software. We're enabling. We're not making the choice for them. We make certain choices in terms of how big a cluster is, where it's located. Hopefully, for the sake of team culture, you're making that choice together with the other teams. But if not, that's also cool. Sometimes an application team might not know these things. They might not care about these things. So however you make those choices, that is what we've done here today. And if we jump from our clusters to our workloads, let's jump to our console workload, Vault workload. And let me close a few things here for you to make it a little bit more visible. Remember how we said we've deployed this on DigitalOcean? I've got a pretty nice setup here on how to do this with DigitalOcean. And the way this works is, imagine that the Vault subdirectory is essentially our application team, a team that's tasked with deploying Vault. Same could be true for any other application. Maybe it's Nginx. Maybe you're running some complete different workload. That team needs to get the kubeconfig from somewhere. So let's look at the process of getting there. We'll start by knowing that we've deployed on DigitalOcean. So we'll define our provider. And you should be able to see that on screen now. I've highlighted 4 lines. Same as before, we provide a token, which we have put as a sensitive variable into our workspace. So the application team can have access to the API, but doesn't necessarily get the actual token. So we don't have to worry about leaking it. It's secure and it works. Next, we need to configure our Kubernetes and Helm providers. To do that, we're going to switch to a data source. And in this case, we're using the Terraform remote state data source to retrieve the outputs from the outputs workspace. That sounds a little bit confusing, of course, but if we switch back to our our Terraform Cloud setup for the outputs, naming is sometimes really hard. You'll see what I'm talking about. This object in outputs called clusters contains all the information we want to have. So you'll see same workspace name here, and that enables us to retrieve some information from our output dynamically. So again, as before, we're in the outputs workspace. And what I'm going to do is I'm going to start Terraform console and make sure that that output actually contains what we want it to contain. And as before, for some reason, my editor decided to not work with me today. So let's see if we can fix this real quick. If not, that's also cool. We'll just work through it in Words. Yep, looks like definitely we're working through this in Words. So we'll just do it in Terraform, much easier. So we've got our remote state data source, which matches this here. We're grabbing the outputs, specifically clusters. And if you remembered before, in docs, one of the outputs that we stored was cluster name. And this is really all that we need, because with this DigitalOcean resource, the read resource for DigitalOcean Kubernetes clusters, and these resource names get really long, allows us to retrieve everything we need to know about our cluster. And so if we go to our outputs window, and let me open the console here, and then type in the what is it? The console. There we go. Let's open that one up. Of course, this path would not work the second we want to do it. because that would be too simple. What we're essentially doing here, retrieve the cluster name, and that gives us access to all the important information from our Kubernetes configuration and our actual kubectl config. And what we're doing here then is we grab the CA certificate, base64 decoded, because it is stored as an encoded, base64 encoded string in the API or in the API response to the data source. We're grabbing the endpoint, so which server we're actually talking to. And in the case of DigitalOcean, we're grabbing the token from the kubeconfig. Now, if you're doing this on something like GKE, AKS, you might not be using the token. You might be using the client certificate and the client CA certificate, but the process is still the same. With this information, we're configuring our Kubernetes provider, which is nice. Very simple. We're giving it an alias of docs, and then we're doing the same for Helm. DOKS, DigitalOcean Kubernetes Service, makes it easy for us to see what we need to know. And it's also the same abbreviation we use throughout the rest of the code. Now, here's where it gets really interesting, I think. We've deployed one cluster, and I don't know if I can deploy a second one or redeploy a second one because the others take a little bit longer. But let's have a look at our module. Now, if you look on the middle of my screen, you're seeing a Terraform module. This is a local module that we have defined here. And pretty much all we're doing, other than passing in a root token for the purpose of this demo, we're defining a provider. Specifically, we're saying this module needs a Helm provider, needs a Kubernetes provider, and we want to have the reference for docs in there because that makes sure that the Kubernetes interface for this module reflects DigitalOcean. So let's say you wanted to do this for GKE. Note how I've highlighted those 9 lines, copy pasted them. And what we're going to do next is call it GKE. We're still using the same module. Call this GKE as well. And as long as we have a provider defined for those aliases, this is all that you need to switch your workload from DO to GKE. Define another provider for AWS, switch it there. Now, we're doing this on a cloud-by-cloud basis, but there's nothing stopping you from doing this on an environment basis. Hopefully, you're using the same exact module in production as you used on testing. Maybe testing is a version ahead. But either way, you want to make sure that the stuff you're using is the same across all environments, because that way you're ensuring that your infrastructure as code actually contributes to a better experience. If you're doing stuff in testing manually, but production is code-based, as in infrastructure is code-based, then that's okay, because at least production is codified. But you're not necessarily going to be able to replicate the same exact environment, because humans clicking in consoles will sometimes lead to mistakes. It's also a lot of work. I prefer not to have that much work, so that's why codification is much easier. So let's take away the GKE module because I haven't configured that right now. And let's see if we can deploy this while we have a look at DigitalOcean. And maybe not, my editor will decide to work with me on this. While we do this, let's see if we can get Vault deployed real quick in the last couple of minutes. And we have Terraform starting up. You'll see that we're actually pulling in our module. And rather than wait for it, let me show you what we're doing here. We're using a Helm release resource in Terraform for the Helm provider that we configured against DigitalOcean. We're specifying the repository to be one of the HashiCorp releases. If you have your own Helm chart for Vault or for your own application, feel free to change that. Specifying a chart version. Please note that that's not the Vault version that you're deploying. That's configured separately. We put that note into the code, but it's good to call it out because we all know two hard things in IT: caching, naming, and off-by-one errors. And so we want to make sure that this here is the chart version. When in doubt, over-document your code, right? You're working on this right now. You might be working on this 6 months from now. Maybe 2 years down the road, somebody looks at this application and goes like, wow, this is a work of art. But I have no idea what they did here. Put in as many comments as you need. Code and version control doesn't care about this extra line, but the humans reading your code will. This line here lets me quickly click and see when I'm signed in, which of course is gonna take longer because something expired right now, so we're not gonna do a sign in here, but you would be able to see all the releases of the Helm chart. And that's useful because then you can also look at the various change logs. You can see what we need here, what maybe we're deploying version, what is it, 0.16.1. Let me scroll to that real quick. And you can see it's still being deployed. We have a Vault setup here. So sometimes that takes a little while longer. And that's all we're doing here. Very simple code to get all your software released, nicely encapsulated in a module that we can reuse through 4 different clouds or through 100 different iterations on the same cloud. If you use infrastructure as code, you know this concept. It's a good concept. If you are new to infrastructure as code, this modularization and pre-packaging of what kind of resources we need is a game changer. It makes it so much easier to do all this kind of fun stuff, to do it reliably, to work on it with your team, and to see what's happening. And in our case, what's happening is that we deployed Vault on DO. Took us 2 minutes, 35 seconds. We've got 1 resource currently deployed, so let's switch back to DigitalOcean. Let's see if there's anything happening in our metrics. For me, it's 1,800, and you'll see that there's a little bit of load average change over the past 5 minutes. We started about 3 minutes ago, so this checks out with us actually deploying a workload. We can see our memory usage went up. That makes sense. We deployed an application. Our disk usage also went up. Again, we deployed an application. Bandwidth usage, not very heavy because we're not doing a lot other than quickly downloading a chart. And that's pretty much it. This was a very simple way of showing you how to deploy various applications on multi-cloud Kubernetes with Terraform, all from the comfort of one code base. Now, we had the link for this in the chat. We'll put it in the show notes. Feel free to grab the repository. We've got issues enabled. We'll be using that repository for tomorrow as well and for Thursday. And you'll be able to just follow along. If you have any questions, feel free to drop them in the chat now or ask them in the issues. And with that, thank you for joining today's deep dive. Please come back tomorrow and check out what my colleague Rosemary is going to be doing. And have a great rest of your KubeCon.